So welcome to Vegas Programmers. So I guess before we get started, who here is like a aspiring programmer? Never really got, don't have a job yet, but thinking about it. Okay. Who here has a job? Intern. Okay, cool. So I think everybody will get a little bit of something out of this. Pardon the dust. The presentation I put together fairly quickly, and obviously there's a lot to go through here. So what I would suggest is if there is parts that you want to dive into deeper, where you want me to actually show more examples or something like that, let's go ahead and do that. So feel free to raise your hand at any time during this presentation. You're not interrupting. I'm here for you guys, right? And girls, I'm here to serve, right? When I first started programming 10 years ago, there were no meetups, which is why I started Vegas Programmers, was to give that community outlet to give back in a way, because had I had this sort of ability to network and learn from others, it just gives you a boost in being able to get your feet wet and learning how to get into the industry. So just as a quick thing, 5 years ago, after doing 5 years of software development, I started obviously with this meetup, not with the intention to find clients, but everybody would ask, hey, do you know a software developer? Do you know a software? So eventually I just started my own business, and now I do, for 5 years now, I've been doing freelance software development. Worked on a bunch of different projects, a bunch of different languages, and the best part about it is now I can fire my boss if I don't like it, right? So, but before that, I had to basically put the work in to get where I'm at. So, but the day and age that you guys are in now is awesome because of the remote opportunity. COVID completely flipped things on its head. And there is a struggle still between kind of corporate wanting people in the office and people going remote. And to be quite honest with you, I think there is benefit if you have a mentor in office to take a job in the office for a bit. Because having somebody to tap that's right next to you, that's how I was able to get learn so quickly, right? On the shoulders of giants that I was leaning on for advice, and people who are by far smarter than me, right? You'd never want to be the smartest person in the room. That's kind of a key thing. So if you ever do have questions in the future, advice, whatever, email me. There's some contact information at the end here. Happy to answer any questions or provide advice as best as I can. Before we get started down the whole programming thing, I just want to I threw this slide in here because IT isn't just programming. You're not just writing code and doing all that kind of stuff. There's a bunch of different avenues, and your personality type, who you are as a person, what interests you in life, can lead you down certain paths that would make work not feel like work, right? If it doesn't feel like work, you never have to work a day in your life, if you ever heard that saying. And that's exactly why I threw the slide up, because for example, I know a guy 10 years ago. He was a starving artist, if you will, and he was a graffiti artist, which is funny enough, right? Super talented. Did murals in people's backyards and their house and all that kind of stuff, but just wasn't paying the bills. And then he got the nudge to go into designing, to graphics designing, UI, UX, and he had the eye that it took to transition into that, and now he's one of the best designers I know, right? So people who have an eye for finding problems in things, quality assurance QA, that could be something that if your attention to detail, meticulous, like project management, QA, that sort of thing. If you love working with people, which not all programmers do, if you love working with people, management is a great way to get in. And albeit it's hard to just get right into a manager role, it could be something that you're happy to grow with. I know plenty of programmers that have been given their management role and reluctantly taken it because they don't like managing or having to worry about firing people or something like that. Maybe that's just something they don't want to deal with, right? There are also within IT itself a whole bunch of different avenues even within programming. So I know full-time sysadmins. They love Linux. They love the command line. That's their thing. They don't know how to write code. They barely know how to read code. But they know how to set up a web server. They know how to install packages. They know how to update those packages. They know how to keep a system up to date. They know where to look to find security vulnerabilities. Those sorts of things. Pen testing. There's a whole bunch of different avenues you can go down. And it may feel overwhelming in the beginning, but trying a little bit or maybe watching a couple of YouTube videos about people in these fields will give you insight into what interests you. I know a couple of people who they just love hacking, right? They love, maybe they were one of those kids that took apart the radio when they're a kid. Maybe they didn't put it back together, but they've went into pen testing, security, InfoSec, that sort of thing, because that's just what interested them. So don't force yourself to go down this rabbit hole of just learning how to code if within the next slide here, you don't have all of these qualities to do it. And if you don't, it's not a big deal. Again, there's so many different avenues here that you'll find something right that's for you. The word programmer can be is kind of convoluted because it's all these different titles. It's all the same, in my opinion. In the beginning, you may be handed a title of Python developer or whatever because that's like the avenue you've taken. But I would always suggest never cubbyhole yourself. When you're first learning to program, especially in any of this stuff, fear can take over that, oh, I'm not good enough, imposter syndrome, like I don't know what I'm doing, whatever. Nobody knows 100% of everything, right? So you just kind of have to get, and maybe it's, if anybody was here for demo time before, whether it be the Kennedy method or whatever they were talking about, getting your brain trained to just push through that fear and learning is kind of the key thing about it, right? And not being afraid to reach out and taking the time at the end of the day to just try to learn, right? So from what I've kind of gathered from the teams I've led, the people I've worked with, some of the best traits I've seen in really good software developers is self-reliance, which basically is like independent working, right? Or the ability to not only work in a team, but to not also ask the same question twice to a team member and trying to figure it out yourself, right? And once you've exhausted those options, then go and try to seek help. And you know, if you know multiple languages, I've seen people excel at learning programming languages. I'm not sure, I only know English, but I've seen that in traits in people. Logic. If you can logically, and this happens sometimes when you're doing software development, where you actually build like a mental map of the application in your head, right? Like I know here's the entry point, it goes and calls this API and does X, Y, and Z. If you can logically think through things, that's like a huge benefit, right? Attention to detail. Most of the time that's how bugs happen, is because you just kind of got lazy with one part of the code, you just got it done, and come to find out there's something going on there. Again, you can't like hone in and do it perfect the first time. It's all iteration, right? Some of the best systems out there running our water treatment plants still get patches and there's bugs and there's vulnerabilities. It's like nothing's perfect out the gate. So it's okay to make mistakes. abstract thinking, trying to think of other ways to tackle things. One of the biggest problems I've dealt with when you're focusing on an issue is you start to spin your wheels. You spend so much time on just this one little thing. It's so frustrating. Most of the time, the way to solve that, backing away from the problem, taking a 15-minute walk or whatever, trying to reevaluate the situation. You'll hear like rubber ducky method and other things where it's like, talk to me like I'm 5, and you explain the issue at such a low level that eventually you kind of come up with a different way of trying to tackle it, right? Patience, you just got to. This is why my wife will never do programming. She just doesn't have the patience for it, and some people don't. They can't sit in front of a computer for 8 hours a day. That's just not their thing, right? So it's completely fine. But again, if that's not something that you like to do, and you also have to cut yourself off too. You can't be sitting in front of the computer for 16 hours either. But you have to have the patience for this stuff. You're not going to learn everything overnight. And strong memory helps, right? And again, you don't have to know all the things all the time, but being good at note taking, being resourceful, back to one, being able to go. Most developers, when they're beginning, and even when I was, you're basically a glorified Googler. You're going through Stack Overflow, you're trying different snippets of code, and you eventually find something that works. The key thing is understanding why that works. Don't just take an answer for face value, but understand why that works. So these slides may jump around a bit. We're going to kind of hop around on a lot of different topics here. So again, just raise your hand if you have questions as we go through this stuff. In programming, or in even computer land itself, there's basically what are called stacks. And so you very well could, not only in an application there are stacks, but even within just your computer itself there are stacks. So everything is built on top of your system architecture, and then you may have a database that's layered on top of that, all the way up to your actual application layer. I don't know why that got so fuzzed out, but anyway, we'll go through a couple more slides that'll talk more about stacks, but the whole key here is that everything is just like layered on top of each other, and you don't need to be an expert in every single one of these, right? For me, yes, I know a lot about programming, but I'm not a network engineer. I don't know all the layers off the top of my head. I don't know all the little tricks and things like that. That's a whole nother profession, is network engineering, right? So as long as you know the basics about a lot of these things, that's enough. You don't need to become an expert in all of this stuff. So in programming, there are basically what are called primitive types. There's true and false, the very, very basic most value in computers itself. I guess with quantum computers, there's now probably a 2 or something, but that's what we got right now. 32-bit, 64-bit processors. Everything at the end of the day is computed down to a binary value. Then at another layer on top of that, again a layer, is the integer. So using a whole bunch of binaries, they create a value called an integer, which is essentially just a number. There are signed, meaning at the very beginning of an integer, there's a flag that says true or false. If it's true, then it's a sign. If it's false, then it's unsigned. All that means is if it's signed, this flag is saying, hey, this can be a negative value. And then if it's unsigned, it cannot be a negative value. It's always a positive value. So that's just if you ever hear signed integer or unsigned integer, it just means whether it's a negative or not. Or I should say signed does go into positive, but it can be negative. But signed is always positive. And then you've got floats, which is basically just you're going like Bitcoin status and going, out point whatever, which are in here is just calculated with multiple values to calculate that. But again, all of these different things really at the end of the day is just a long string of these binary values that create these. I don't know how to make an integer with binary or whatever. You don't need to know that stuff. I mean, this is just, again, just the basic stuff. As long as you know the structure, you're good enough. The computer does it all for you. I'm not a math major by any means. In fact, I have no idea how I passed calculus in college, actually. Probably was on a curve because everybody failed it. But there's the char, which is basically a character, a single character. Multiple chars together makes a string. So that's that. Those are your primitive values. On every programming language, you're going to be dealing with those primitive values. A layer on top of that, again, is what we call objects or classes. So name, age, height. This is an object if it's built. If you're just looking at what we'll call contract of it, this is like a class itself. Once I create this class, it then becomes an object, because now it's a class that's been created that has values in it. Josh, 36, too short. Struck, this is very similar to an object. You'll see this in Golang, C, very low-level languages, but essentially at the end of the day, it's kind of like a class or an object. And then lists or arrays are multiple of a thing. So if I have a bunch of people in here, that's an array of these people objects, we'll call them, right? And a list is basically the same thing. Sometimes lists can be ordered lists, sorted lists, things like that that add a little bit of logic on top of an array that makes it a more structured list of things. It could be a list of integers. It could be a list of strings, array of strings, whatever. At the end of the day, it's just multiple of something. And then an enum is an enumeration. You can, for example, like if you built something and it can have 3 different colors, red, blue, yellow, right? Well, you would set those values, and those become a static array, and that you can set it as an enum. So you can really just think of it an enum as like, I only ever have these values. It never changes, really. Although you can update them. Typically, it's like a static thing. It stays that way. You'll run into what's called constants and then variables in programming. Constant just basically means once I set this thing, that's it. It's not changing. I want it staying this value the whole time, hence constant. And a variable can change. It can be modified at any time, hence it's variable, it's dynamic. So a variable can be anything though, like I mentioned before. It could be an integer, it could be an array, whatever. So back to stacks. This is a little bit more detailed and readable. But essentially, there are different stacks within your actual application itself when you're programming. And knowing a little bit about all of these is good. But as long as you know a lot about this layer, you're a programmer. You don't need to understand the deep workings of Windows or Mac or how layer 5 networking works or whatever. As long as you understand how to write an application, how to debug it, you're good. So again, don't feel like you need to become a master of all.
Is that based off the OSI model?
I believe so. Yeah. I'll ask you guys questions during this too. But yeah, so knowing how sessions work, that's important. But again, knowing like the inner workings of sessions isn't necessarily important unless that's your job to handle that. And sometimes in the beginning of your career, you're going to have to wear a lot of hats. But again, that's where Googling and playing around with things, that usually gets you past the finish line enough to launch something. A little bit of just basics about networking, though. Here is just an example of your home computer, and you have an IP address that's a private IP address because you're in your house. And this router dishes out these IP addresses every time a new device connects to your network. However, your router connecting to Cox or whatever ISP you have has a public IP. And there are private ranges that are reserved for routers and things like that. And then there's a ton of these public IPs that are dished out everywhere. We're running out of IPs, which is why eventually we're going to go to IPv6, but from what I've heard, that's not going to happen anytime soon because apparently there's issues with that. But anyway, this is the basic flow here. So if you're trying to get a hold of bbc.co.uk, this kind of flow of a web request goes out, and that's coming back to you, and there's a whole bunch of routers in between you and whatever destination server. And again, I know very little about like BGP protocol, and there's like a whole bunch of networking stuff. Again, if you're not a network admin, you don't need to know all that stuff. But as long as you have a good grasp of IP addresses, what a CIDR means, which basically just means a range of IPs. So with a CIDR, you can say 192.168.0.1 all the way to 255. It's just like a way of signifying here's a range of IP addresses you can use. So knowing that kind of stuff is good as a base level. Understanding ports and protocol types, there's basically just TCP and UDP. I think there's others, but those are the two that you should know. TCP really is just like, it requires a handshake. So when I send a request, I'll get back something that says, okay, yes, I've received your request. UDP is used a lot for things like little monitors for like landscaping and whatever, like these little internet devices where UDP packet gets sent out and it doesn't care about whether it received it or not. It's just basically like throwing a ball over the wall and not really caring whether the other person caught it or not. So typically most things is TCP. When you're making a web request or loading a website, all of that's typically TCP. But lower level, like Internet of Things sort of devices, sometimes they use UDP because UDP is faster. You don't need to wait for that handshake to come back. The most two important ports of going through software development that you'll need to know, is port 80 and port 443. And those two ports are probably going to be the most important ones you know. There will be other ones you run into down the road, like MySQL, which is like 3306. And basically, these ports at the end of the day, all it really means is your computer needs to talk to some other, whether it be an application on your computer or some other computer within your network or in the cloud, whatever, that needs to go over a port. So although I've said here's the IP address, I have to also signify what port that request goes over. So HTTPS, it's going over 443. If it's unencrypted, it's regular, you don't see a lock on the website, it's going over port 80. Sometimes at the end of domains, you'll see colon and then a number. That means it's signifying the port. You can actually force it to talk over a different port. So sometimes, if you're developing locally, for example, and you're using port 888 or something, you could very well put localhost colon 888, and now it just is talking over that port instead. At the end of the day, it's just signifying what lane of traffic within the network stack to talk through. And just basically, again, if you make a web request, there's an HTTP call, and that HTTP has a whole bunch of headers and stuff like that. It's super blurry, sorry, but essentially in an HTTP call, when you're making a request to a website, you're saying what page I want, what method, there's get, post, a whole bunch of them. But essentially, most of the time when you hit enter, you're doing a get method. Just give me the web page. If you're submitting a form and you're submitting a contact form, those are typically a post. You're sending additional information a part of that request. You're not just saying load this page for me. So knowing these methods is really important if you're going to get into web development. You don't need to know much about protocol versions or anything like that. But having a rough knowledge of headers is a good thing to know. You don't need to know all of these things. But the basic ones like user agent, this is the type of browser you're using. what you're accepting back as the response. You can signify that. If I want JSON back or XML, you can signify in here, hey, I want this type of information back in this format. So you can kind of specify that. And typically at the end, you'll have a body. If you sent, like for example, in a post, when you submit a form with your name, email, whatever, all of that will go into the body here. So on this slide, I just wanted to show a little bit of HTML. Again, you don't need to know all the HTML blocks, but if you know the rough HTML schema, it's good enough. So again, we talked about in an actual web request, this is a web response. We've made the request. Now here's the response back. It will tell you, hey, what happened? In this case, everything went good. We got a 200. There's a list of numbers that we'll get into here in a second that signifies whether something bad happened or something good happened. In this case, 200, everything is good. These are the response headers back. Just like how we could give headers for a request, we'll receive headers on the response as well. In here, this will tell us how much data is expected back. This tells what content type they've signified here in the body. And some other information like when the last time this thing was modified, the date that this was sent, what web server version sent this. Typically, you don't want to expose this because that gives hackers a way of knowing, ooh, he's using an old version of Apache. I can attack that or whatever. But just as an example here, you can specify all kinds of headers. So if you open up a browser and let me maybe open up. Let me actually get back to this because there's something else I want to show in. I'll show you Google Developer Tools and in Chrome, and we'll go through all this kind of stuff here in a second, actually, because there's a couple slides later that talks about a couple other things that relate to that. HTTP status codes, like I mentioned here, when a response is given back, there's ranges of these codes. If it's within the 200 range, you know everything went good. If it's in the 300 range, that means that the page that you've requested isn't actually there anymore, and you need to go somewhere else. So this will tell you, hey, go to this web page instead. And that's sometimes when you see your browser, it'll load the page for a second and then all of a sudden disappear and then go to another website. That's just doing a redirect. 400 means something happened on the client side, meaning you sent a bad request to me. Whatever you did in your request is no good. If a 500 happens, that means something on the server side blew up. So their code's broken and wasn't able to process your request correctly. So this is really bad. This means you wrote some bad code. This could mean that there's user error, or it could mean some of the code that you wrote isn't sending the correct things when it's making a request. And 100 I've never really dealt with. I think it's informational. So I don't know. I've not had experience with that. So now we're going to dive into an application a little bit, talk a little bit about more internals of an application. We kind of covered networking and stacks and things like that. So now we're going to go more into application flows and logic and stuff like that. So the most basic rudimentary example here, this is a typical workflow. You can use something like Scratch. There's a bunch of, there's a tool in Python as well where you can basically build these sorts of workflows. So it's like a GUI that you can just build your own, hey, if this user input is true, do this. If it's not, do that. So at the end of the day, most applications can be broken down into a workflow, right? So if I'm on Facebook and I hit follow, it says user request follow, add them, okay, and return a response or whatever, right? So most applications are a lot more complicated than this, but just giving kind of a basic example of kind of a workflow here of how an application may work. There's a whole bunch of different languages out there. You don't need to know them all. This is a little old too, and in fact, there's a lot of, I would say, inconsistencies in a lot of the graphs I've seen out there about what the popular languages are. So it may be kind of confusing what you would want to pick for your first language. But I guess out of the people that are new here, who here has like worked with JavaScript? Is that your first go-to? Right, and that's a great first go-to. Reason being is because JavaScript you can write both back-end and front-end code if you learn it. But if you know JavaScript, you know PHP also, because JavaScript has a lot of similarities to that language. So again, just because you think you only know one thing, you've probably already learned 80% of another and just don't know it yet. A lot of other languages, that you'll see similarities in them. And when it comes down to it, most languages have, there are what's called interpreted languages, meaning, for example, PHP, when I write PHP code, that code isn't just automatically executed face value from whatever words I wrote down in that script. Those blocks of code that I wrote in my PHP script get compiled down to C, and then that C becomes a binary that runs. So an interpreted language at the end of the day, it just means it's taking that, what you wrote, and converting it to lower level language, and then executing it. And then a native language is going to be something that's executed directly. In most cases, something like C, C++, those get compiled languages, compiled into a binary, and that binary is actual execution bytecode. That's what your CPU is looking at. So you'll hear things like, oh, Java is slow. Well, that's because, and it's not, but you'll hear things like, oh, PHP is slow, or this is slow, or that's slow. Most of the languages that they say are slow are because they're being translated, if you will, into executable code. At the end of the day, again, you don't need to know all of these. What I would suggest is wherever you're interning or you're planning on trying to get a job or something like that, or maybe something in particular interests you, like game design or something like that, that's probably where you want to hone in on that particular language, whether it be Unity or C++ or C# or PHP, Java, whatever. So I wanted to show this graph because this is, again, just to show the inconsistency of these, like, oh, what's the most popular language right now? None of them are accurate. But consistently, you'll see ones at the top, JavaScript, the C's, C and C++, .NET, or what's called C#, Python, PHP, Java. So, and Objective-C, that's really just like iOS devices and stuff that you can write apps or whatever. So, and then shell language, like that's like CLI scripts and stuff like that. You're typically running that. So, I guess before we go further, does anybody have any questions about any particular languages they want to hear about? Maybe they have some question about a particular language or something they want to know about one versus the other. Oh, yeah.
I noticed you didn't have React up there. Notice React was up there. Where does that fall in the spectrum?
So React would be actually considered, I guess there's two different types of Reacts. I think what you're talking about is the UI, like building like components, right? That's in the JavaScript realm. So that's in JavaScript, you know, well, in any language, you'll have what's like called frameworks or libraries. React is a framework that's built on top of JavaScript. So all the React code really, at the end of the day, is JavaScript underneath the hood. But most of the time, these things like React, they'll add their own layer on top of JavaScript to make things easier, right? Like if we wanted to write this pie graph, for example, in React, that would be a lot easier than us trying to hand code in JavaScript from scratch how to build a graph, right? React's already got it done. And leveraging open source projects is like the keystone of why software development's such a flourishing thing now. Because 20 years ago, GitHub and all that wasn't as popular. Oh, I would say open source itself wasn't as popular. In fact, the guys who ran Microsoft before, they hated open source. They wanted proprietary code. Everything should be in-house. Why would you want to share your code with the world? They can hack you or blah, blah, blah. All that's changed. Now Microsoft loves open source because they've seen the power of it, because it's like kind of that crowdfunding mentality. Now you're throwing the weight of the entire world at solving a problem versus 20 people in a cubicle trying to solve the issues, right? Thousands of other open source people are going to find problems with the library and help you fix it. And they're not asking for anything but maybe a little credit, right? So open source is great. There's still proprietary code out there. I deal with it all the time. But at the end of the day, most proprietary code uses a bunch of open source projects, like libraries, frameworks, or whatever under the hood. But React's a great framework. But you'll see things like Vue or other competing ones. Again, don't be afraid to just try out other ones, but then honing in on one is eventually what you want to do, right? Like, don't feel like you need to master both. Most of the time, your job will dictate what you need to really understand.
Really quick, would you say overall, like learning C before JavaScript would be a good idea? I mean, I learned JavaScript before I learned C, and I kind of wish I did the opposite, because I know JavaScript takes a lot from C. So would you say learning like the grandfather languages before learning the newer languages like JavaScript is a good idea, or should you just find something that would work for you?
Yeah, so personally with my path, my very first programming language I ever used was called Blitz Basic, which was based off of this programming language called Basic, right? And then later on I did, my very first job was in C, actually. We did mainly C code, which was drastically different, right? Just the whole paradigm of it, right? C, you're at like, basically, this is bare metal, and then C's right there, right? JavaScript, there's like probably 3 layers in between that. So it's much more high level. But in JavaScript, I could write something a heck of a lot quicker because there's all of this helper stuff that's there. Versus C, you are so low level that you can't leverage all of that open source stuff to make things quicker, right? So I would say each person's journey is going to be different. But at the end of the day, knowing C and JavaScript is better than you just knowing one, right? And again, you don't need to be perfect. But if you just took a basic course in C, just to know, again, going back to what we were talking about, structs, that's all C. The difference between C and or C++, they just added classes and objects in here. That's really the main difference. They said, I'm sick of dealing with structs all day because structs are very rigid and you're just defining this exact thing and I can't really change things once it's created and add things onto it. That's when they were like, screw this, let's add another layer on top of C called C++, and then they added classes and stuff. So knowing a little bit about those is good. Again, and I've made this problem in my career too, but thinking, okay, I'm just going to put all of my effort into knowing, and like, for example, PHP. I've been in it for so long, and I kind of started screwing myself a bit because jobs started disappearing from PHP, and Python was growing a bunch, and all these other languages were growing a bunch, and I wasn't keeping up with those. So that's where I said, whoa, let me start writing some Python. Let me start learning this and that. And luckily, getting opportunities to work on projects in other languages, which is pretty common if you're working in a tech company, or any company really. Most of the time, not everything's going to be written in one language. You're going to have some computer under some dude's desk where he wrote something in, Java 6, and nobody wants to support the dang thing, and it's just been running for 10 years. Don't touch it. But one day it breaks, and everyone in the office only knows C++. No, you just having a little bit of knowledge in Java, you could save the day. But and again, it's really just more on the lines of just having enough troubleshooting experience with other languages translates to other languages too, right? And we'll talk a little bit about that more here in a bit. Okay. I need to kind of speed it up a little bit. Whole bunch of languages. Again, most of them are just built on top of other things. But at the end of the day, what I would suggest is you can kind of experiment with a few of these. You don't need to do them all, but find a job or an internship, and that will kind of lead your way into whatever languages that eventually you'll need to then hone in on and really understand. And what I would suggest is if I got a job in C#, go to GitHub and follow all the big C# projects and get integrated into the community. Most of the time there's Slack or Discord groups or other things you can get connected with. And that's a great way for you to find jobs there, because most of the time there's job boards there. That's a lot of way I've found new clients and stuff like that, or other people, other developers, and become ingrained in that community. Because then you'll be at the point to where you can start attending conferences for C#. Tell your boss, hey, we're doing all this C# stuff. I want to go to the C# conference. It's going to make me a better developer, and I'll be able to bring back to the table and show all the other developers cool things that are coming out in C# to make our life easier. Then you'll get to a point to where, hey, let me submit a talk to the C# conference. You'll meet so many people in that community. You get ingrained to that community. You learn about what the pain points are. You learn about other technologies. Again, trying not to be the smartest person in the room. Going and interacting and networking with other people. That's a key for you to kind of stay on top of the trends of software development. So like I showed in the beginning, really that logic flow at the end of the day is back to binary, right? When you check a value, is this condition true or false? And that can be stacked on top of each other. So it can get a little complicated where it's like, if this is true, then do this. Otherwise, if it's not, do this. And that can have kind of a flow there too. So this is where things like classes are great, because you can encapsulate logic. This can be one class. This can be one class. What's called spaghetti code or procedural code is if you have one file that's 10,000 lines long and it's just a bunch of these. Super hard to read. That's why objects and classes were invented to begin with, is to make a 100-line class that's a heck of a lot easier to read than like a 10,000 line long script, which I'm sure one of you guys will run into eventually anyway. And then there's if checks, so if else, like there's those sorts of checks, but within that, there is also loops. So you could have a while loop, in this case where it just sits in this loop over and over, checking something. If it's true, keep going through here, then eventually, oh, okay, it's done, and it kicks it out. So that's a while loop, and then you have a for loop. Again, fuzzy, but essentially it's the same thing. But you may have some more conditions in here. So for example, you have like an array of items. I have 10 items in this thing I need to process. Let's sit here 10 times, do what it needs to do, then kick out, and you're done. So essentially, kind of like an example of a loop here. Well, actually, more lines of an example of a function. This function here, you'll have parameters in your function. So here in this function, I have x and y, and those are the inputs I can provide to this. This function will give me back the max number here. So if I provide two numbers, it's basically going to just say, is it greater than or less than? If x is greater than y, return x. If it's not, then that means it's either equal to or it's less than, and kick back the other value. There's a whole bunch of these condition checkings you'll need to learn. Greater than, less than, equal to, not equal to. So and these all translate to all languages. So pretty much once you get a hold of this, all the other languages are pretty much the same. And then these are parameters. This is what this function can expect. But once you actually implement it and pass things in, those numbers are arguments. So I've given this function max these arguments, and then those arguments are then processed here in this function. But the actual definition itself, these are parameters. Here is just like another example of that, just showing a little bit simpler. It's just adding these two values together. So value 1, value 2, addition. So on top of checking whether something's greater than or less than, you can provide things like, I want to multiply this, divide, etc. You'll have different ways of doing that. As you can see, plus, pretty straightforward. These are just adding these two values, and you're returning that value. So over here, you would probably have a variable that would say a equal, and then sum of this, and then a would now equal those two values added together. And then jumping back to a class a little bit again. So in this example, we have a person class, and we have all these different kind of things on the person. This would probably be an integer. This would probably be a string. This may be an enum, right? Male, female, whatever. And then occupation, a string saying what occupation they have. Functionality, all these functions on this class. So if I want to make the person walk, I would create the person, and then I would execute on that person. Okay, go walk, go sleep, go eat, whatever. So that's what a class typically has. It has not only these attributes, but then you're going to have functionality inside of there. So again, all that encapsulates into one thing that you can interact with. Now, if there's a bug, when I told the person to walk, he fell on his face, there's probably a bug in here, and I can debug in here. Versus having a long procedural script that does all this stuff, it's going to be hard to read through the code and debug. And speaking of debug, debugging is the key to any of these languages. Like, at the end of the day, knowing how to use your debugger is going to be your best friend. Sometimes it's a pain in the butt to set these things up, but spend the time to do it. Because if you try to use logs or like just echoing stuff to the screen, it's the wrong way to debug an application. In not all scenarios are you going to have the liberty of doing debugging. That's where knowing other ways to debug is going to be awesome, because you'll have other tools in your tool belt. But this is tool number one. If there's a bug in your application, the dude fell on his face when we called walk, let's put a breakpoint at the beginning of the walk method. And when we call walk, let's step through line by line. And all of these variables in here will show you exactly what they equal. So as I go through this code, these values may change, and I can see at what point, oh, when he took a step tripped over the other foot and it fell, right? So this right here is the most important part of your debugger, is being able to look at these values while you're stepping through your code line by line, and then finding the line that's broken, and then perhaps maybe putting in some checks in there to say, make sure the other foot isn't crossed over the other one or whatever, right? So other things in your debugger you'll see is, again, stacks. So this stack here always has an entry point. So when you execute something, you're always going to be saying, launch it. We need to perform this action, so call walk. At the beginning of your application, it's going to enter the application. Then it's going to traverse through your code to eventually call the person walk method. So you have to look at this as just kind of like a breadcrumb trail through your code. Each one of these is a class, and it's stepping through the classes to make its way to the final point that you're debugging. And at any point, if you think, oh, maybe something above this code where I called make has sidebar, maybe something above this provided an incorrect location. So you may want to drop a debug breakpoint in one of these instead. So you would just click on this, put a breakpoint there instead, and now it would stop there before going into this extra layer. So there's different ways to step in and out of code, but essentially it's just stepping line by line, or stepping out of this and going back up a stack, or stepping into another method, like this get sidebar is another call, so it would put another line up here. That right there, we may want to step into that. So that's where these little things right here are your navigation to step through your application. And if you found the bug and you're like, okay, just play the rest, you can hit your play button here, and it just runs the rest of your code. Or if you're just like, man, this thing is completely jacked, I'm going to go get coffee, just hit stop, and the whole thing will just blow up. So does that make, yeah?
Sorry. Do you want to finish that question first?
What's up? No, go ahead.
Do you make a lot of custom WordPress templates?
Do what?
This is a WordPress template, right? Do you make a lot of custom WordPress templates on your
I have. I don't really anymore, but yeah, I have.
Okay.
Yeah.
I'll come to you after later on for PHP advice for it. Because I have clients on my personal clients on my own that I'm working on, like a law firm in Vegas that I'm building custom templates for, but I just need more understanding of creating templates from scratch and modifying them and saving them for templateable project for the future.
Reach out to me, and then offline we can talk more about it. I can give you some advice there. Yeah. But my heart goes out to you. WordPress is its own beast. Like it's not what I would call a modern framework. It was built however many years ago, and the interesting part about WordPress, their mythology is that they want to support the oldest versions of PHP that you could imagine, which means that the code has a whole bunch of like crap just kind of sitting there to support all of this old installations, because most of the time people install a WordPress site, leave it sitting there for 5 years, and never update it. And WordPress doesn't want to break that. They don't want to break all of these people that have, and so that's kind of what it is with WordPress. But anyway, I'm happy to talk more about that later. Yeah. Logs. So in your application, you may have something where, hey, I want to actually output this location here. Like, hey, here's my location. And that will go into a log file. So your logs here will have a whole bunch of things in here that will tell you more about what's happening in the application. Logs are super important, not only because of you working locally and understanding when certain parts of your application were hit, but also once you launch this thing into production and it's being used by real customers, you don't have the luxury of using your debugger anymore. Once it's on a remote server, you cannot really, and you should not, hook up a debugger directly to a production server. It's bad practice. You should debug locally and figure out what the issue is. So most of the time, it's trying to recreate whatever happened on production on your local machine to find out what happened. And logs is the best way to do that. Because on production, you can see, oh, right here, error, MailChimp, top bar, this API error happened. Let me look in my code. I'll typically just grab this string right here, search my entire code base for this, find the spot that this is getting logged, and now I'm where that error happened. So then I can drill around in that code and figure out what happened there. Design patterns are kind of a layer on top of programming. Again, I mentioned procedural is like the worst one. You have one file and it's doing all this stuff. But eventually, once you have classes, you kind of have to organize those classes in a way that still makes sense. And that's where these different what I would call design patterns come into play. The most important one to know, you don't need, in fact, I know probably only 2 or 3 of these. The most important one to know is the MVC design pattern, model view controller. And essentially what that means is that when I make a web request to submit a form, I have a contact us form. When that request of all the information about that contact form comes in, this controller here, I would then load it into the database. So this model would be a model of a table in a database. So I'd load all that information into my model. And then for, let's say I may want to show that same contact form on some administration page that some admin can view all of the people who have contacted us. Well, this view here can tap into that same model, take all that data, and give that view back. So this right here is HTML, basically your presentation layer, all your HTML code, how the website looks, all that stuff stuffed in here. How your application stores data is here. And then the logic of the entry point is here. Sometimes there's a little bit of a layer here of service, a service layer, where there's some additional logic. You don't want to have long controllers because then you're back to procedural coding. You want, like, if I need to send an email, I'll have like an email service here that I'll call, send an email, and it's not all that code to send the email is right here in the controller because there's 20 other spots in my application where I need to send an email. So if I have that one spot in all my different controllers, I can call that one thing and send an email. So again, the other one, if you are interested in learning more, I would also look at domain-driven design. That one's also really good. So those two are the main ones I know. You'll hear a lot of in the JavaScript world, it's observer pattern. But yeah, so. Licensing, we can kind of just roll right through this, but essentially when you build an app or you're going to use like an open source project, you want to make sure that I'm allowed to use this thing and what type of permissions they give me to change the code. Maybe the thing does 90% of what I want, but I need to change 10%. So am I allowed to make that 10% change? Some licenses will say, if you make a change to this, you have to give it back to the community. You have to like help us improve it. So that's where some of these licenses you may run into that. To be honest, in the beginning, don't even worry about this stuff. Most of the time, you'll have like a VP or somebody in charge of making sure whatever you're using is cool to use. But at the end of the day, most code's proprietary within organizations, but a lot of them use a lot of these other licenses underneath the hood. But like I said, in some cases, you may need to worry about that stuff. And don't get into the habit of trying to reinvent the wheel. Leveraging APIs within your app is going to be your go-to with a lot of stuff. So there's a ton of different stuff out there. It's hard to keep up, to be honest. So don't be afraid to just pick a couple of the top ones, try them out, see which one you like the most, and then just roll with that. So does anybody have questions about like APIs or anything like that in particular? Yeah.
Yeah, I'm trying to build like an e-commerce site, but I don't know if the best approach is to hire like a third-party company that has like some kind of what is it called? Like a processing.
Payment processor?
Yeah, like a processor, something like that, or if I should just do it on my own, just incorporate the APIs of like Stripe or Square for my own personal website. What would be the best approach to get it in my store?
Yeah, so, WordPress has like WooCommerce, and there's a whole bunch of plugins you can just plop in for Stripe and all that stuff. Makes your life super simple. If you're talking about a custom application that you wrote, then there is no plugins for you can't just like one-click install something. You're gonna have to write a custom implementation against one of these payment processors. So what I would say is that answer depends on what your application is built in. If you use Shopify or something, Shopify already has that stuff covered for you, right? Because it's like a common use case. If I have a shopping cart, I need to charge credit cards, right? So, but yeah, Stripe is a really good one. Square is also a really good one. So those two I would take a look at. Alrighty, and then you'll kind of hear like software as a service, functions as a service, database as a service, platform as a service, hosting as a service, all this kind of stuff. And at the bottom of it, infrastructure as a service. So AWS, GCP, Azure, all of these different ones, they provide, rather than you having to manually go to switch, put a server into a rack, maintaining that server, keeping it up to date, all that kind of stuff. This, again, this is where all this stuff makes your life super easy. So you don't have to be a sysadmin. You don't have to be, too low to the bare metal to get something up and running. So there's a whole bunch of things that you will want to use a part of getting something to market quicker. So storage as a service, if I need to store files, I would probably use S3 or Dropbox or one of these. And these all have APIs that you can just send a file up there. When you need to download it, there's another API to download the file, all that kind of stuff. So don't be afraid to use this stuff. And there's most of the time already open source projects are out there that you can just install into your framework and start using these out of the gate. So that was a lot, right? It was like a lot, which, it's okay. What I would recommend is if like you're super green and you're just trying to break into the market, I would recommend going to upforgrabs.net, or there's a couple of other websites like this, or go to GitHub. Sign up for GitHub, and if something interests you, like React, for example, go to React, go to the project React. Typically, you'll want to star the project, meaning you kind of like a YouTube, like you subscribe to them. And in that project, you're going to see open issues that they have. One of the, in my opinion, because I've seen people who have known nothing about coding and have got into programming, start with just by updating documentation. It's like one of the actual biggest problems with building open source software. You build all this whiz-bang stuff, but nobody actually documented how to use this stuff, right? Or typos, like somebody just spelt something completely wrong, or maybe it's not clear enough. Adding the documentation is a great way to kind of get your feet wet into a community, help give back to them, build your name with them, and also get to meet people in that particular thing you're interested in to help grow in there. What this also gives you is a resume builder, because now you have a GitHub profile, where on your GitHub profile, you put that GitHub profile in your resume, and when the person goes to pre-screen you, they're going to go to your GitHub, and they're going to see that, because it's all public, they're going to see that you've followed React, you've closed an issue with React, you have commits that you've pushed up and actually helped resolve issues with these people. That, even if it's documentation, they don't know. Most of the time, they won't actually dive deep enough to see what you did. They'll just see that, hey, he's got green boxes, meaning that he's pushed up code, which is kind of like the number one thing. You don't want to get a job and then be asking people, hey, how do I push up code? This is stuff that you definitely need to know before going into the interview, because they don't want to be dealing with somebody that just needs hand-holding the whole way. Again, self-reliance. Like, there's thousands of YouTube videos on how you can contribute code. So upforgrabs.net's one. There's a whole bunch of others. But this is basically just a list of projects that need help, right? And what I would suggest is in this list, start with projects that need help with documentation. Because when you go there and start contributing to the docs, you're basically reading the docs on how to use the thing, and then you can start to actually help with the code eventually, because you know how this thing works. You've read through the docs back and forth, and you've fixed things in the docs that were wrong. Then you can start helping out. Now, again, in the beginning, you're not getting paid for this stuff, but there are issues out there that have bounties. So there are people who make it their living of going to open source projects and literally just tackling bounties. $50 if you can fix this problem, right? There's even like on hackerone.com, if you can hack this website or do something here, In some cases, they pay 6 figures, like if you can hack certain things, right? So again, don't be worrying about money in the beginning. My first job, I was getting paid squat on 1099, but it's that foot in the door that matters the most, because from there, everything's going to be just a step ladder up from each position there, right? So, but my key thing is, if you do start to work somewhere, try to get somewhere where there's other people. Like if you're just a solo person building something, try not to stay there too long, because learning from other people is just going to make your career speed up a heck of a lot quicker. So this is basically what a GitHub project looks like. You go to the GitHub project, you'll see all the code, you'll see a bunch of folders where all the code's maybe thrown in there. This is the name of the project here. Above this, I don't have it listed here, but you'll see things like issues and other things where you can go in there, see all the open issues. But the biggest thing is like following it. So you click this little star, and that will subscribe you to it. Anyone that goes to your GitHub profile sees everything you've starred. So again, if you're going for a React job, I would recommend going to every React project that's popular, starring it. Now when they go to your GitHub profile, they're like, oh, this guy actually is following all these React things. It just gives that little bit of validity that, hey, you're serious about this stuff. And again, there's a bunch of YouTube videos, but learning how to commit code is the key to programming. So typically you'll have a main branch, and this is always stable. They don't want to break this because this is what's getting released to the public. When you make your change, so for example, documentation, there's going to be a file here called README, or under doc, there's going to be just some simple text files with all the documentation there. You'll go in there and make your new branch. So I'm fixing issue 1234. You'll name your branch 1234. You'll commit your change, update the documentation, and then you'll create a merge request to pull this back into the main branch. So you'll click this fork button. This fork button does this. It forks this off and makes your new branch, right? So that's where you'll make your changes and then submit that pull request. Once somebody gets around to reviewing what you've done and merge it in, you're now a programmer, even if it's documentation. That is literally like, this is every day I'm doing this, right? So if you have this down just in a basic sense, this can get nasty, by the way. Like there are forks of forks of forks and whatever. But this is the basic example here of kind of how this works. I'm sure everybody tells you this stuff, but yeah, YouTube's good. I would just recommend, don't go too far down the rabbit hole of YouTube. Most of the time, I'll Google something first before I even attempt to YouTube it, because most of the time, 80% of the content's not something you're interested in. So try to Google it. If not, there's a whole bunch of stuff out there that you can kind of follow along if you're a more visual person rather than wanting to read crap. That's a great way to do it. And then nowadays, you're really spoiled because you have AI. So one thing that's changed in the last year for me and how I do programming is, in some cases, most of the time, I will ask ChatGPT, and there's also Google Bard that you can use. Both are free, although if you want to use 4.0, I think you have to pay, but 3 point whatever is free. It's good enough. And this is free right now, so I'd recommend Google Bard if you want to check this out. But go there, and let's say you wanted to write the custom WordPress plugin, right? You could just say, hey, this is what I want to build, and unbelievable. Like in 20 years, this stuff will probably be doing 90% of our work. At the end of the day, they'll still need humans because this stuff ain't perfect. There will be bugs in the code, but most of the time you can have a conversation with this thing where you're like, hey, this isn't quite right, this broke here, and it will go, oh, I'm sorry. It actually apologizes sometimes, which is funny. And then it'll give you new updated code, and then you can kind of go and try it out. One key thing though, a lot of these models are built off of models that are a couple years old. So if you're using something cutting edge or a new version of something that's added a lot of new features, this stuff ain't gonna know about it. So Most of the time, if it's something that's been around for a few years, this stuff will generate it for you. So for example, I had to learn how to build like pipelines recently, and I just used it to do it for me. So snapshot this. This is my, my contact information. You can follow me on Twitter, Instagram, whatever. That's my social. Email is probably the best way to get a hold of me. And then my website, remotedevforce.com. Before we log off here, I would say I've got 2 free JetBrains licenses. They sponsor this user group. So if you do PHP programming, Python programming, or you're just wanting to learn, you want to use a good tool to do your job, JetBrains is great. So email me. I have 2 free licenses. First 2 people to email me, I'll give you those licenses. It's a 1-year free license to the best IDE that you can use for programming. You can use VS Code and stuff like that. Those are free, and those are fine. That's a great way to get into it. But if you're doing stuff day to day, you're going to want to use something serious. So let me just show this, and then we're going to split. So I'm in Chrome. I right-clicked. I hit inspect. This is what I do most of the time when I need to debug like a website. From a front-end perspective, this isn't going to show server logs, but it'll show front-end logs. So if I click console here, this is a log. When I went to google.com, they've actually got some errors they probably need to fix like underneath the hood here. But I'm sure most of the time you'll see a bunch of stuff on the front end where it says it's an error, but nothing broke on the website, so they don't really care. But I wanted to point that out, and then I wanted to point out in JavaScript world, this is really powerful to debug code, because you can go into sources and find a particular JavaScript file and look at the JavaScript code here. So in this code, we could find something we want to debug on the front end and drop a breakpoint there. You can click add breakpoint. And then now when I reload the site, it would stop on that breakpoint. And then, like I mentioned, we have the whole stack here on the right where it's showing where we're at in the code and variables and things like that. So that's a great way to kind of play with a debugger a little bit. Yeah, I guess that's it. So again, if you guys have questions later on, you need advice or something like that, reach out. Also, Joshua Levitt, who runs Tech Alley, he runs kind of like a intern type of thing where they'll try to place you with a company here in Vegas. I'd recommend reaching out to him if you're looking for an internship or something like that. He's got a lot of connections with people here in the Valley, so that's always a great way to start too. Does anybody have questions before we log off for the day? We good? We're all programmers now?
Earlier you mentioned that on Slack or GitHub, but you were able to find communities on there to look for jobs. Like, how would you be able to search on there? Just go on Slack and just search communities, or how would you be able to?
Most of the time when you when you go onto a community, for example, like I joined the Symfony community, so it's a framework in PHP. Here in there's going to be a bunch of channels, and there's a jobs channel here. So you'll find something like that. Cool? All right, thanks everybody. I appreciate coming out. Yeah. Oh, yeah.
So there's a market. When you learn programming, you become an entry-level developer, right?
Uh-huh.
Like a junior.
Yeah.
But most of the jobs in the market doesn't say anything. Either doesn't say anything or it says senior. It doesn't say junior. I would say it's like maybe like 1 or 2% of the whole job market for junior positions.
Yeah.
So should you apply for only for the junior or wherever it matches your stack?
I would aim for mid-level. If you don't even bother with the senior ones, because they're obviously looking for a senior. But there are quite a bit of mid-level. But again, where you're going to have to start is some internship or a junior. But at the same time, once you've got a couple of years experience, tack on that senior title and call yourself a senior, because most of the seniors I know aren't seniors. But so.
Also, like how do you feel about it? The market in 2023 getting low, is
Yeah, again, it is a very competitive market, but at the same time, that's where networking comes into play, right? Like going into the jobs board and posting, "Hey, I'm a junior, I want to learn more, blah blah blah." Someone may reach out about an opportunity, so you need to get connected with the community that you're interested in, and find somebody within to hire you, because most of the time those junior positions get hired by a referral or something like that, right? So networking is the biggest part of that. Yeah. All right. One last one. Yeah, we got to split. So.
Do you know 100 devs? What do you think about them?
Which what was that?
100 devs.
100 devs. Oh, I've heard about that. I can't. I don't have experience. I don't know if it's.
I use them, and it's just like for anyone that's new here, if you want to check out 100 devs, they have YouTube videos. During the pandemic, this guy was trying to teach people how to be a programmer from scratch with all the tips for getting jobs and everything, all the languages from HTML all the way up. So if you want to Google, there's classes already pre-recorded, so you can always check that out.
Yeah. That's another thing. If you're having struggles with like self-taught, those are ways to get it. And also there's boot camps and stuff like that out there where they're free. They just take like a percentage of what you make for a couple of years or something once they place you. But yeah, thanks again, everybody. Appreciate you for coming out.